So, do you want me to start? Rose? Hello?
Yes.
Can you hear me?
Started.
Yes, we can hear you.
Oh, great. So once again, good evening. I'm still your tutor for manual testing, majorly software testing and everything. So we'll begin again today's class, and I'm still Yemi Ayola. So still manual testing class, continuation from the last session we had on Wednesday. So today, this is our topic for today, and the topic we'll be dealing with today is SDLC and STLC. So if you're joining the class for the first time today, I would so much advise you watch the last lecture we had. Is mainly the foundation and the background. So most of the things I've been saying, you will also hear most of them also in the lecture. So I've told you that their background, there are things that you will continue to hear. But if I need to go through some recap, I'll still do that at the end of the course just to let you know what we did cover in terms of high level. So this class today will be mainly focusing on LDLC and STLC. So my task today is to let you have great understanding of both sides. What is called, the title, their roles, what the expectations are. So that takes us to our learning objective today. And this is what are the learning objectives for SDLC. I'll talk about SDLC. I'll talk about the different models of SDLC, pros and cons, and that's the advantages and disadvantages. I'll talk about the concepts in understanding. That's the understanding testing. So mainly, this is our learning for the first part of is SDLC. So if you can just know from that meaning, you would have seen SDLC, Software Development Lifecycle. We'll still dig more into it. So predominantly, software development lifecycle. Some people call it iterative and incremental development model. You'll have an understanding about it when I go further. There are the various types of software development lifecycle, various ones. So we talk about the rational unified process, there's Spiral, there's V model, the Scrum, Kanban, Agile. We've got Agile, we've got Waterfall, and V model. So all these are just example of various software development lifecycle. But if you've looked at it, we've got quite maybe like there are more. Well, majorly these are the ones people really speak more about. But there are three major ones that we talk about mainly when it comes to software development lifecycle model. The three are waterfall, which is called linear model. We talk about V model, which is called sequential developmental model. We talk about the iterative, which is called incremental development model, and that is called agile. This big guy here, this particular guy, that's the main person that is really happening in the market now. As I've said that he is, some people still practice the traditional way, which is the waterfall. We'll also talk more about it, and I'll let you understand from this perspective. But always remember, these three are the key thing that we really use now and the understanding of it. Hence, our lecture today is going to be based on the three of them. But you having to work in the internship, this is what you are going to practice. This is how you are going to work. That's the iterative incremental, mainly agile. agile. So make sure that your pronunciation is some of these things are key. So it's agile, agility, quick, quick. So those are the meaning of that. That takes us further to the lecture. So what is software development life cycle? I've said the acronym previously to say software development life cycle, SDLC, or software development life cycle, is a process that produces software with the highest quality at low cost in the shortest time possible. So the essence of software development life cycle is that we need quick product to be out there. We don't want to sit on that product. We want things to be going as in flowing. You've done you want to prepare a meal. The first thing you want to do is you want to get the ingredient. Let us all know that you want to prepare the meal. These are the ingredients. So you carry every one of us along. That's the essence of development life cycle. We want every one of us to be part of it. Let me know what you're doing. Give me something to give me something to show that yes, you are actually developing something. You're developing a product. You are working on an application. You are cooking. Let me know that you're cooking. So when you want to start cooking, you want to start preparing. So by the time everybody knows, oh, you are getting various items, then they know you want to cook. Then it not streamlines that what type of item are you getting? Then it takes you to further to let others know that, oh, with everything she's getting, she wants to boil a rice. With what she's doing, this is what she's heading to do. So we'll go further down from there. SDLC provides a well structured flow of phases that help an organization to quickly produce high quality software. High quality software which is well tested and ready for production use. High quality software. So we want to be we a software that is well tested. What do you mean by well tested? You have adequate time, specified time to test it. How does this work? Is that if you are given an application or when you're working in an agile environment, we know we want to build an application, an e-commerce application. Is we all know how e-commerce is. You go there, you shop, you pay, make some payment, and that. What software development lifecycle is preaching is that we want to do these things in bit, is properly tested before the full application comes end to end. What do I mean? We want to test an application, an e-commerce application, as an example I've given. The first thing we do, we know the process. The first process will be we need an environment where we want to do it. So first, maybe we get a host, we get a domain. That is sorted. Once we get once the domain is is done, the first thing they give to you as a tester, test the domain. You check it. Is the domain coming up as expected? Yes. Don't forget, we know it's e-commerce we want to. We want to shop, we want to set for item, we want to pay, we want to get everything delivered on. But we are still testing the host, just the link to know that this is the domain, this is the environment, this is the website link that people will use. That's the only thing we're testing. So once we finish testing and we know that domain is fine, the next thing is that we want a page that people can log in. That's the next item. We pick that item, the developer will build that item. How we as software tester will start testing just the login, do various scenarios. Now, you come to your mind that why are we doing this in bits? Look at how long I tested the domain properly. At least we will know that like 80% of the bugs would have been fixed, found at that phase. We take login again, we do the same thing. We take launching of the application, we do the same flow. Then at this phase, we have good time to do proper testing, fetch out the bugs before it goes live. I'll elaborate more as we go. Then, before I continue, I want to talk about let's understand what a life cycle is. I took this example as chicken life cycle. If you know the egg that we eat starts from somewhere. So first the egg there's a egg for when the egg is laid, there's an embryo in it. So that's the chick. Then it start hatching, it breaks off. Once it starts hatching, it turns to a chick. From the chick, by the time it start eating and doing this, it grows to an adult. Now take it again to you and I. We did not grow up just like this. We were formed in the womb. After 9 months, we came out. From there, we were babies, toddlers. From there, we became child, teen, adulthood. From adulthood, old age. That's still life cycle of human. So predominantly, that's the same life cycle we mimic when it comes to software development life cycle. So this is just an example to bring fresh memory of what a life cycle is. It's similar to how it is. What it means is that this chicken did not just be turned to an adult. It started from somewhere. So it's from egg laying. If there is no egg, there will be no adult. That's what it means. If there's no conception, there will not be you and I. That's the thing about the life cycle. And that takes us further to more details about SDLC. I start the acronym. I'm letting this come to you so much because everything you're going to be doing in IT world, talk about IT, you're going to talk about these guys. SDLC is, I said software development life cycle. This is a big word, it's big tax. Development team is big, is wide. We as tester is just one role in the development team. There is business analysts there are scrum masters there are project managers there are solution architects there are various roles. We've got data analysts. All these encompass the big name development life cycle. You are going to see a difference when we get there. So that's the acronym software development life cycle. It is also called software development process. Is a framework defining tasks performed at each the word each step in software development process. That's why if you see the life cycle of that chicken that I put, the egg is one phase. When it starts inside that egg is the embryo, it starts growing. That's another phase. When it hatches, that's another phase. It turns to chick, it's another phase. Then to adulthood. Take it again. Let's bring it to the e-commerce application I was talking about. The first phase was we understanding what the domain is, what they are giving us. The next phase was logging in. The next thing we want to do to have a website where we can launch to see it. Inside it, we need to know the various items loaded there. We need a search to be able to search ad. So it is framework that it performs, that is performed at each step in software development process. So that takes us continuation of it. I will keep emphasizing because I want you to when you say it like this, I found out that most of the time it sticks to the students and it sticks, you will understand it because interview question is going to come very soon. There's difference between software development lifecycle and software testing lifecycle. Two different things. So that's why I said if I say it more, you'll have the clear understanding of what it means. So it's still software development. It refers to a methodology with clearly defined processes for creating high quality software. In detail, the software development lifecycle methodology focuses on the following phase of software development. One, requirement analysis. Two, planning. Software design, such as architectural designs. Software development, testing, deployment. It comprises of all this. So that is these phases are what we are going to treat one after the other. So that takes us to the life cycle. So one is requirement analysis, what I've mentioned, design, development, testing, maintenance. The deployment and maintenance come together. That takes us to this particular framework, this model is what it takes us to the first one. If I could remember, I said three are the ones that we use. The models that we use are three. I said waterfall, I talked about V model, and I talked about agile, which is the iterative incremental model. So I will start with the first one, waterfall. If you look at the name, waterfall, look at this picture. If you look at it, it shows like a waterfall. Hence, it bets the name called waterfall model. Reason is that if you look at the way the arrow is going down. So if you go to waterfall to see, you could just see the waterfall down. What is the meaning of this? The meaning is that this first person is requirement analysis. So this requirement, who are the people that engage in requirements? We will explain it when we get to agile. We all are meant to be, but for this part of model, you need to understand how this model works. This model, the way it works is that in requirement phase, we've got business analysts, we've got product owners. They are big brains that speak to the clients, get all the information that we need as development team. We are not in the picture yet. They are the ones that will get it. So when they understand what the client wants, they do a detailed document of the expectation of the client. Liars signed off. Once they're happy with it, and it's been signed off that the client says, go and go and get us the e-commerce, go and develop the e-commerce application now. After the requirement is done, they give it to the design guy. Who are the design guys? Solution architect. He looks at it, the requirement. It brings out a flow. It draws a diagram of the connection, the connectivity in terms of it. It brings the picture out for us in full details to let us know. So once the design tool will look at it, everything that these business analysts have given me, is it what I'm designing? I mean, this is what the expectation is. Once he finishes, that's end. He ends. Don't forget, requirement, the business analyst, they finish their own part. Sorry, they finished their part. Now they've sent it to the design team. After the design team, then once the solution architect finishes, he sends it to the third guy. Who is this person? It's a development team. Who are the development team? The developers. So what the design person has drawn, they start coding to develop with what the design has done. He also finishes his own bit. Once he finishes developing the application, full application, he sends it to testing. Testing, testing. Who are testing? You and I. We are the testing team ourselves. Will be coming in, and after then, deployment is done. It means we finish testing, we deploy whatever has been tested to the user's environment. And once the user's environment is done, then maintenance is in terms of us helping. What do they need? What so maintenance in general. Now you'll all be wondering that how is it like this? Requirement finished. He didn't even say anything to this design guy. He just gave him document. The design guy just drew his own part and gave no communication until what happens in this phase is that if you are building a product like this and the client has given you 2 months or 6 months to deliver the product, let's use 6 months. If while they are gathering requirements, they need to be meeting with the client. It can't be done every day. They have their schedules too, so they have to work at it out. Maybe the requirement takes 8 weeks. That's 2 months to gather the requirement. The design team will also need like a month to be able to design it. That's 3 months. The developer will use nothing less than 2 months to do the same development. That's 5 months. Don't forget, we are hitting the target of 6 months to be delivered. Now bring it to testing team. We cannot test in 1 week. It's not possible. A full application. You are just going to bring out. So we also might need another 2 months to test. That's 7 months. Of course, it's tight deadline. That we need to do the deployment. The deployment is to take some phase. We are going to meet some issues while deployment and things like that. So let's give it 1 month. That's already like 8 months. We're already 2 months behind. Now, the question is that when it gets here, it might get to the client when we deploy. They might not like the application. It might not even be what the expectation is. So once it's not their expectation, they cannot release it. What we'll have to do is that we'll take back the application to the beginning again, start doing requirement gathering, design, so everybody works in bit. The difficult thing here is that if it's a complex application, it's going to take forever. You keep looping because there's no communication. Once requirement finishes, he puts off his hand. We don't know what is expected. There might be things that you don't understand there. There might be things that we should have highlighted to the to business to say, oh, this flow will not work. It won't work. So how do you want us to do it? So they'll go back to the client. So those kind of communication are key. So that takes us further to the meaning of it. So linear, that's if you can see, is a linear form. This means that each phase must be completed before the next phase can begin. So if requirement gathering does not finish, design cannot start. So all of us have been waiting for 7 months without doing anything. Waste of resources, waste of time, waste of money, everything. So we all have to be working in loop. So phases do not overlap for each phase. Goals are defined. They must be achieved and signed off. So that takes us to the first one, requirements. What are the requirements? Who gather it? The user's business required are defined. Design, the system design, architectural design are defined. Development, code is implemented in small program units and tested. Testing, test plan, test script systems is tested end to end. So that will be end to end. User testing is done. Deployment, product is released into customer or user environment. Maintenance, to resolve customers' environment issues. So those are the way these phases work. What is the advantage? The point is that phases are processed and completed one at a time. Works well, works well for small projects where requirements are well understood. What do we mean? What is small project? Maybe just like a one-page website. We all understand what it's going to do to be able to view that website, read the content, be able to link to social media. Just one page, well understood from requirements. So you don't need much. This will work fine if it's understood. But what's the disadvantage? Complete a stage before moving to the next. If something is wrong in one stage, there is no chance to go back. This is an expensive model. So that's the advantage and disadvantage. So let's go to all the things that we have mentioned. Requirement gathering analysis. So understand the proposal put forth by the customer and then gather their requirements for a suitable solution. Be sure to probe as much as possible to gather as much information as you can at this stage. So that is where you'll when we probe, we ask them when a business analyst brings it. Two heads, they say, of course, are better than one. You might have gathered all the information. No, this is done and there. But when we all come together in a room and you read the first to us, we can give you various scenarios. If I tell you to do login phase, I can say, did you consider this? How do they want to log in? How is the security? What is the expectation? All that you can be bringing into light. They might not think of that scenario to that point, but when you have a lot of people in the room, it brings things up. You got and you can ask a lot of questions. Go back to the client. They come in, explain, gather enough information. That's when you are doing the requirement gathering session. This phase is highly documented so that developers can revisit requirements at any time. That's the requirement. So the next phase is planning and design. What is planning and design? This is where you elaborate on a project plan for meeting those requirements laid out by the customer. Once you have a plan, design concrete specification for the developers to utilize, like screen layouts and other materials. So they give this when you are doing when the design, when the architect is designing. If he wants you to do something like the login, this is how we want it to look like. He can bring it in form of a picture, design the picture, give it to him because they code according to what they see, according to what they are given. That's the way the developers code. So during this phase, you need to analyze the problem in the context of the organization policy and objectives. So we just need to understand, have a clear screenshot, a detailed um, a detailed project plan to let us know that this is what is expected. Tell me in a lay language that we all understand. Don't make it too ambiguous. Make it as easy as it is so that people can navigate around. That's the essence of an application. User friendly, easy to use at any time. That takes us to the third one, building. What is building? That's the development phase. So during this phase, the actual code is constructed. So it's done by the developer. This can be done by a single developer, a large team, or even several teams, depending on the scope of the work. So that's the determinant. So it depends on the project. In various organizations, there are various projects. So you have various developers, various testers. So they need to be developing. It depends on how big the application is. That is the determinant of the resources you're going to use. When I mean resources, you and I, we are part of the resources, solution architect, developers, business analysts. Resources is all because if I'm working on that project, I'm also going to be paid. You will also be paid. So all these are put into consideration. You will understand further why we put all this in. So developers will need to track changes to the code, and if there are different teams working together, that they are able to know what others are doing. So now if you've got big project, we are all working in with a project, like the developer has to, all of us are working together in one project. You don't want to give three people one task to do. It's not cost effective. So telling someone to repeat to do the same task that someone, so you have to give them different tasks. So that's why I said it depends on how big the application is or what you're doing. So it's a determinant of how the development lead is going to spread the task across. Changes could be documented either formally or informal. That takes us to the fourth one, testing. Testing, that's you and I. Now that the code has been written, it's time to test. Usually, this is done in special environment, and I'm going to explain that to you. In testing, we've got different environments. What do I mean by environment? When the developers are developing, they develop in the dev environment, which is development environment. What does this mean? Is that in development environment, the configuration there is, I would say, they have lots of config that works absolutely well in that environment because it's code. They need to test it, they need to see that it's working as expected. So all that thing is done in any bug, anything they want to do, everything is done in that dev environment. So the dev environment is a big container, big one that has a lot of things inside it. So if you have a big bowl, you put different things inside a big basket. You've put clothes, items, shoes inside that. You don't want to, when I ask for a dress, or if I ask for clothes, I don't want to take clothes, shoe, bags, tops. You don't want to put everything in the test environment. No, we've asked for clothes. Put the clothes in test environment. So now, what does now, after the development environment, the next environment we have is a test environment. Now, different organizations with various test environment. Some call it SIT environment, which is system integration environment. SIT in stands as SIT. You can say SIT. That's when you sit somewhere. SIT. But the acronym of it is System Integration Testing. That's that environment. It's a it's a test environment where we tester. It is our environment. We own that. Some organization might also have various test environment. They can have like 5, 6, 7. It depends on how big the organization is. If you, if the, I've worked in organizations where there are various environment, and the way we do it is that if a test environment is busy, Yabi, my team is using one test environment one. Your own team might be using test environment two. Another team might be using test environment three. Now, if everything is occupied, we ask, when are you going to be free with this? We take up that environment and we use it. So it depends on the organization. But as I said, it depends on how test environment they are built. But the main thing you need to understand today is that we've got the development environment, we've got the test environment, which can be called SIT environment. We've got the third one, which is UAT. UAT. The acronym of UAT is User Acceptance Testing. User Acceptance Testing. So it's an environment. Look at the word I said, user. So it could be, we also, as a tester, your job as a tester is to test like the way the users are going to use outside. So anything you are thinking when you are testing, remember that you are representing the user when you're testing. So that's what your job is as a tester. So once you finish in that environment, you go to UAT. Sometimes there are different teams that run UAT, which I always prefer, because if you've done SIT, you are already used to the system. Remember what I said about general testing principle. That's what I told you that in the last class, whatever I was telling you, we are coming to use it here. So general testing principle, that brings us to pesticide paradox. It doesn't mean because you keep running a particular test, you are going to find new bugs. No, no, that when you keep running a particular test, that it means that that test is passed, is looking good. No, it might not be bug free. I can honestly tell you that when you move from SIT to UAT, if it's picked by another person, you will be asked that, did you test properly in SIT? It's always like that. Now, you will ask me that, what is the reason? Someone else is looking at it from another point of view. That is the way it works. So this is where our general testing principles come to now. So someone else is testing it in the user part. Then the way UAT is always like a mirror of what production is. So in SIT, the configuration might not be as big as it, because what is the reason is that we need to also be cost effective when things are done. And because of this, I'm taking my time to explain this, because most of the time we have issues that people need to understand how this test environment works. So now, after UAT, we have pre-prod. What is pre-prod? Pre-production environment. In the pre-production environment, if you take a mirror and you look at yourself in the mirror, is the way you look, that's the way you see yourself in the mirror. Correct? Yes. So now the pre-production is just the mirror of what we are going to see in life. So anything that is going to happen in life, you are doing it in pre-production. Who are the people that go to pre-production? They are business users. Who do we call business users? The main people going to use the application. So when we deploy from UAT to pre-prod, those people are going to test there. You would ask that, why are we taking it through all this phase? Is to make sure that it's error-free. At least little things will be what will be fixed in production, because when it goes out, remember, Consequences of not testing properly would have been taught in the first class when it comes to error, defect, failure. Before then, we said consequences of not testing. Why do we test? The consequences: loss of business reputation. So you don't want to, loss of money. You want to be careful that when this application gets um, to production, it doesn't. When people start using it, the meat something good, high quality, well tested in production. So after pre-prod is production. So I've mentioned 5 environments to you, starting with the development environment owned by the developers. The next phase, once the developers finish, they put it in a test environment. Test environment is owned by we testers, UAT. Next one too, we also can test in UAT, pre-production. It depends on your organization. I test at every level of that. So it depends on the assets and it depends on how you can test. So those things to bring it to your level of experience to bring it. It's not that if you start today, if you're meticulous and you know what you're doing, to be honest, you'll be to test in production is very easy because this same deployment has been moving from one environment to the other. The last phase is just for us to test before it goes public. So that's it. So that's it about test. This test environment I've said until you stop testing career, this is the how it's going to be. I said until you say, "Oh no, I'm not doing testing again." Until you are out of IT, that's when you won't hear about everything I've been telling you about this test environment. That takes us to the fifth one, deployment. How is this done? Everything that we have tested, I said, the way we are moving from one environment to the other, that is deployment. So it's done. It runs through a pipeline. It's being deployed to all the test environment. So the last one is maintenance. Maintenance phase. During this maintenance phase, the software is maintained so that it stays effective and relevant. Tweak can be made to the initial software so that it remains a viable solution that is free of bug. So, maintenance. When you're trying to maintain things, you're trying to fix your car, you're trying to maintain it, you take it for checks. So the same way we are maintaining application. So that's the explanation of that for that. And that takes us to the next phase. So those 6 that I've explained to you, take that same understanding all through the phase of software development lifecycle, all through your testing career. I took my time to explain those 6 because that is our day-to-day activity. Though you are not, you might think you're not part of everything. In one way or the other, I will tell you that we are part of it. You are going to see it come when we start STLC. So this is V module. Now, I know most of you would have guessed that from this, what happened. Let's take it to the picture, to the face of it. So this is our picture. Look at it. V is a V shape. So in this V model, what is expected in the V model is the name of it is V model because of this diagram. So you can see we saw waterfall because it's falling. Now we saw V model. The way the shape is, it's a V shape. So how does this work? The way V model works, it works that at every verification phase, there is a validation. Now, that reminds me, someone in the last class asked for verification and validation. So you need to understand this. Let me tell you, those twin words that I keep telling you, today again, I have another one, and I'm going to add some more to it today. So take another twin, verification, validation. Verification, validation, interview question. Most people mix verification and validation up when it comes to interview questions. I always say this because if you understand this, then you can test with me. You can be part of my team. When I do my interviews, there are key things that I need to hear from you. I don't want things that you have detailed that people have tutored you to say. I want to know that you understand it. I will know someone that is eager and that understands what he or she is doing by the little definition of your understanding with words like this. So verification, validation. I would go to the meaning when you understand this. So what it means is that at this phase, we start with everything that we have here a verification phase, and all these things are validation phase. So in vModel, to every phase, every verification phase, there is a validation phase. So if you want to verify something, you must validate it. So which means user requirement is the first phase. As we have said, requirement gathering. When you do when you have user requirement, that is what we want to verify. The validation to verify user requirement is acceptance testing. So how do we know that this user requirement is correct? We need acceptance testing to validate it. What is acceptance testing? What are the various scenarios? Now we have said login is one of the user requirements that we are talking about now. So what are the acceptance criteria? User must be able to log in with valid details. What are valid details? If it's username or email, so it will be email and a correct password. You also need to, when you're testing, always remember when you do positive testing, there must always be a negative testing. It's two sides of the coin, head or tail. Two sides in life, good or bad. Two sides to testing. So once you're doing one positive, there will always be a negative one. So that's the way it is. I told you testing is part of life. So it's things that you do, good or bad, you take one. So when you do something that is, you have to check it. Why do we always do both? You will understand. So if you're testing, if you only do happy parts, happy scenario, what about the time that is unhappy? You need to validate so that we will know that that unhappy time, people have to be careful. Let's take an example. You are testing a car. The happy part is that the car can go, it can move, it can do everything. You can take it to where you're going to, you can move the car. But the sad part of the part is that if you overspeed with that car, you are not even looking, you overspeed. If it could have an accident, so you need to test that part. How many miles can it go? What is the safety measure for that? So that's the reason you have to do positive, negative scenarios. So the next phase takes us to software application. Software application, the thing to validate software is the system testing. So same thing with high level design. We have the integration testing to validate that. We have detailed design, and that is the unit testing. Unit testing is mainly code. So that takes us to verification and validation phase. So the first one, which we said business, the user requirement. So business user requirement. So a detailed requirement of the software system to be developed and gathered from clients. So business analysts have done that. So once he does that, the testing that will be involved here is acceptance testing at that phase. So it will involve testing the product in users' environment. So we want to test it. The second thing is software application design. Please, before I continue, if you have any questions, pop it in the chat. I'm going to go through the chat, pop it in the chat. Any question, so that you don't forget anything. Please just put your question down. I'm going to answer you. These are new. I'm going so slow so that we can understand it. So, any question, please be popping it in the chat. So, software application design. How will the system work and interact? The functionality of features that goes into the system. What are functionalities? What are the features? Functionalities. The login is a functionality. Talk about search application. Talk about adding to cart. All these are functionality. They are features, things you can see. These are things. So the next thing is system testing. Is what I mean. The next thing for that will be system testing to validate the software application design. So you check the entire system functionality and the communication of the system under development with external systems. So that's where we combine everything together to just make sure we check how that is done. Those are the phase. That's the validation phase. Verification, validation. I've not told you the meaning. I'm going to tell you the meaning after this. So, architectural, high-level design of software. So we are talking about the architectural diagram here. So it talks about the technical detail of the project. Is coexistent of the components that make up the system. So all the components that make up the system. That's why I said that for the architect, is going to link it up like a diagram to say with this arrow, this is the first task you're going to do. It will move up. It's from that diagram, from that link, from those drawings that we understand how testing, how development is going to be done. So integration testing is what we use in validating this. So it's performed to test the coexistence of communication at internal modules within the system. So detailed design. Once our system is ready to use, you may later require change the code as per customers' requirements. So I don't want to really talk much about with the unit testing. Unit testing is done from development level. But having said that, we as testers, we do integration testing, we also do unit testing, which you are going to be taught when in this internship, because the unit testing comprises of code that you're going to write when you start doing your automation testing. So you too, you'll be playing with some code, you'll see how it works and things like that. Please, and please, when we are in this stage, I keep saying it, just little time. I'm not going to take, my 2 hours is going to be 2 hours. I'm not going to teach you more. Anywhere we stop, we continue the class tomorrow. But I always love to make sure that you understand what you're doing. Any assignment you are given, any task you are given to do, your days, just spend your 2 hours diligently. Is within this internship, even after. That's the best. Let me tell you, I've been training differently, but I've not seen a platform that gives full end-to-end workplace feelings like where you are now. What is this phase, the coding phase? So what is the coding phase is? The coding phase is that the code is built, coding guidelines and standards, the code review, code optimization. All these are what is incorporated when the developers are coding. That continues with the V model type. So it's still our diagram. So now it takes me further. I've shown you the verification and validation phase. Now I want to intensify to explain what this means. It's also called sequential development model. It means that for every single phase in the development cycle, there is a directly associated testing phase. This is planned in parallel. It must go hand in hand. Verification, verification, verify. Are we building the right product? That is the question verification is asking. That is what this guy is about. Are we building the right thing? He's asking the question. That is how verification is doing. So, as a user requirement, is the developer will be looking, is this expected? Does this really make, is this what we are actually expecting? They need to know, are we building the right product? Then validation will explain to me and tell me that, okay, you have asked, are we building the right product? My answer now is, does it meet the user's intention? So now, verify. Have given me. I have seen it. This is user requirement. Validation. Now, we'll now look. Is this really what the user is expecting? We have entered login here. In the login scenario, what does the user want? Is it username or email address or user ID that is needed? We need to know. What is the criteria for password? We need to know. What is the expectation for registration? We need to know. So you need to, for every verification phase, there is a validation phase. So when they say verify that this is working as a verify that the login username is email verify that is username we are using. Your own is to validate it. Is it username that we are using? Yes, it's username. So you will try with every scenario of username to validate that question that has been asked. Remember, verification is, are you building the right product? Are you doing the right thing? Validation is that, are we doing the right thing? Okay. Does it meet the user expectation? Now, you should ask me that, how will you know that it's meeting the user's expectation? It takes us back to the requirement. What is written in the requirement is what you follow. That is your rule book. That is your blueprint once it's signed off. So that is how you can validate. So now, when you give me a task, I go to the requirement, I will look at every process for that requirement before I can say I've validated this test is working as expected. So verification is more like asking the question. Now validation is that you are performing the task to answer that question. So in an interview, when you're asked what is the difference between verification and validation, make sure you have a clear understanding. Verification is more of you checking that, are you doing the right thing? Are we building the right product? Validation is that you are checking the requirement, checking all the documents to ensure that you are validating according to what you verified. So, what are the advantage of vModel? Testing early in the life cycle, thereby enhancing the probability of building an error-free and good quality product. Very fantastic model. But now see the disadvantage. It's a drawback. On V model, if changes happens in middle way, then the test documents done along with requirement document must be updated. If the high level design is faulty, we have to go back to everything from the beginning and start updating all these documents. It's mainly a drawback. It's time. And you will see the reason why we said it's a major drawback. So that takes us to end of V model. Then it takes us to the third person, which is software development life cycle. The third model is iterative incremental development model, which is called Agile. One, I said incremental iterative. Increment. One plus one. You do one before you add another one, before you add another one. That's the way it works. So requirements are broken down into multiple stand-alone models of software development lifecycle. The requirements are broken down. So every requirement has how we are going to deliver that phase in every sprint. You will be divided into various groups. You are going to be working at sprint level. This is exactly how you work here. So how does the increment goes? If you see this little diagram, is one. So one is the major thing we've taken the first person. So after we have finished development of one, before you can continue, it will be one plus you would have finished development understanding. Then before you can add another one, before you can add another one, before you can add so you must finish this phase before you can add another one. Finish in terms of, you will ask me, what does it mean to finish? Which means this one, if we as a team, who are the team? Remember, I explained to you when we were doing examples of error. When I say various, error could come in various forms. So different things could happen. And I told you what teams a team is. In a development team, in an agile team, it comprises of you and I as testers, developers, solution architects, scrum master, product manager, um, data analyst. It depends on the application you're working in. So all these, we are all part of a team that we work together to put on that. So if this is the first thing that we all pick as a team. So it means the requirement, the business analyst looks at it, we all go into the room, get an understanding, get it signed up. Well, in this sprint, the developer will develop, just log in. We'll pick the tasks that we're going to work. So once we finish this first one, in that sprint, we have to finish is what we can work on, we take up into a sprint. And after that, we keep that one, we add another one to it, we add another one to it. So it's one before we can form the main application. So we are going to be testing in bits, modules, small. So we finish one login, we keep the code. We keep the code. We'll start another one, search functionality. We keep the code. Once we are fine, we've tested it. We'll finish again. We go to adding to cart. We test that functionality. We keep the code. So that's the way it is done. So you keep adding things, you must finish one before you add another one. So, illustration, each iteration passes through the phase of requirement. So, what does an iteration mean? This first one is the iteration. number one. So what it does is we do requirements, we do design, we do coding, testing, software product increment. So that's the way it is. So in that first phase, then the second phase again, we go back to it. We do development, requirements, design, coding, testing, software development. Software product increment. So we add another one. That's the way we do. At each subsequent release of the system adds function to the previous release until all design functionalities have been implemented. So at every phase, we add new things. So this time, we might just do only login. After logging in this sprint, the next sprint we take search functionality. After search functionality, it must add a value to it. It must add a value. So we've done login. After login, what we need to do after login, maybe to launch the browser. That's the next thing we want to. So we want to be able to launch it. So when we do login and launch browser together, it come together. So that's the way each phase does. So iteration output, partially delivered product. The process is repeated until entire product development is completed. The repetition of this process are called iteration. For every completed iteration, a product increment is delivered. For every completed iteration, a product increment is delivered. What is it used? When is it used? There is a need to get the basic functionality delivered first. That is the need. You will now explain the advantage. What is the advantage? Quick delivery of the model, quick delivery to the market. Let's take an example. You want to develop an e-commerce application. We need it in the next 2 months. The clients need it in the next 2 months. You must deliver something good. If it's 6 months, you must deliver something good, high quality, properly tested, error free. You have designed to say, oh, maybe it's going to go through 6 or 7 or 10 n number of iterations. If we do login, after we do the login, we do the requirement phase, the design coding. We as testers, we will test and test. Then we deploy the login functionality to the users. Please, can you also test? Is this what you want? Are you happy with it? Do you need any tweak? No. Yes, okay, can you change this? And we do it, and they're happy with it. Fantastic. So they have seen the login functionality. Though we have not done the landing page, we have not done the search functionality, but they have seen something. They know we are working on the application. So it's a quick feedback to let us know we have done this phase, then everybody's happy. We know that yes, that is working as expected. Once they finish testing, oh, there's nothing, it's fine. It's working as expected. That is fine from that end. Oh, they've delivered login. They also can be telling people our application is working, we started working on it, start advertising. So it's a win-win from both sides. We have delivered, they've seen it, they're happy. We move to the next task. What we're doing next is search. We'll test the search. After we finish, we deploy it to the environment. Are you happy with the search? Yes. Oh, add this, add that. Okay, remove this, remove. Then when we finish, we move there. So that's the way it works. Customers can provide feedback to each product increment, thus avoiding surprises at the end of development. Requirement changes can be easily accommodated. At this phase, if you tell us that, oh, we don't want username again for the login details, we can change it immediately. You want email, quickly they'll change it, add the code and make it. Oh no, we don't want email again, we want user ID. So we can accommodate any changes at that phase Then the last bit of it is, what is the disadvantage of it is it requires effective planning of iteration. What does that mean? Effective planning. That is what you're going to do. Sprint planning, effective planning. So we must have known in this sprint, what do we want to do? We all come together as a team. We think this is what we want to put, this is what we want to commit into the sprint, and that is done. So, so that takes us to a big picture. So let me, it's just for you to see how it works. So for iteration, the first one, let's say you are in sprint one, the first thing we want to do is, first, we want to build login. So the first one is requirement gathering. We analyze, design. So design includes testing and the likes, coding, testing, doing everything. Then software product increment. One. We move to the next thing. That's the first iteration. The next iteration, we do the same thing. Requirements, analysis, design, coding, the second product is done. So second increment, we do it again for the third one, requirement, analysis, design, coding. The third increment is done until we know the nth number. Till when you are when maybe you've gotten to sprint 20, you've gotten to sprint 10, you've gotten to sprint 8, you've gotten to sprint 500, 500. It depends on how they are going, but it doesn't get up to that. So you've gotten to a certain level of sprint, then you can say we are finished. So this is mainly a picture of an agile environment. So this is sprint in iteration. So another face of saying it, just another one to say. The way it works is the bigger picture of this thing, because everything I've been saying from the beginning of today's lecture, I've been talking mainly about development team. So which includes everybody as a whole, is software development life cycle. So it encompasses every one of us. So the sprint, which is agile, the way you are going to be working is going to be definition of ready. Are we ready to commit into sprint? We've got a big, do we understand the project we are going to work on? Oh, we are going to work on project um, e-commerce, correct? Do we all understand? Do we have everything we want to do? Yes, we put everything in the backlog. What is this backlog? It's like a big bucket, a big, very big bucket. Everything you want to do, anything you understand about definition of it, anything you need to do in the tax you are going to be will be dropped into this backlog. So the developers, business analysts, everything they'll be dumping it into the backlog. We've got the product now. It's there. Everything we want to do gets stored in this big, big bucket, this container. So from this container is where we'll be dishing out food for every sprint. So what do I mean by dishing out? So now you have cooked inside this big pot, which is the backlog. So what you want to be taking is that we want to be taking the food little by little. So what is little by little? Little by little is in the sprint, your first sprint, you want to pick some item. What are the items you are going to work in the sprint? And let me still use the same login functionality. So login is what we are going to work in this item. So we all agree as a team, we are all going to be in the sprint planning together. There are phases. So we call them agile ceremony. Agile ceremony. We talk about the sprint planning, we talk about sprint review, and we talk about the sprint retrospective. Sprint planning. It involves us planning and committing into the sprint what we're going to do in the sprint. So that's where our sprint planning phase is. What is the sprint review? After the sprint, we have developed a login functionality. You need to review it. You need other team members to see how things were connecting together. You need to show the product owner. You need to let them see, oh, this is what we have developed. So everyone sees that, oh, this is the fantastic work that was put into the sprint. Then we've got the retrospective. What is the retrospective? All this ceremony are honed by the scrum master. He or she will put you through when it comes to this. So what is retrospective? Retrospective, in this one, we want to know how the sprint went for you. How did it go? Um, the happy part of the sprint, you can say. So we all have different headers that you can do. What you want us to be doing, what you want to be, how the sprint went for you, what didn't go well in the sprint, lesson learned, what can we do better. So those things are what it comprises in the sprint retrospective. Well, we also have some grooming session when it comes to the ceremony. Agile as a big one. There are grooming session. Who participate in the grooming session? I'll explain to you also. In the grooming session, it could be maybe in the login tax. You need some question or some some clarification. You can bring the business analyst and the developer. Three of you can go into Amigo session, three Amigo session, come together. What does this mean? In that, you'll ask yourself, oh, this is the thing I need to clarify. This is what my expectation. You come together, you talk, and you have a clear view because the three of you, you need the business analyst because she needs to explain further. You need the developer to understand what he or she is going to develop. And you as a tester, you'll be called there because you're going to be the one to test. So that's what we call three amigo session. We have it as a grooming session too where we come together as a team. So, by and large, we have put this into the sprint. When we commit into sprint, then the development starts. Just follow this part from the red part is sprint, then the development comes. It goes amber. We've started development. He has finished developing the login. It takes it to the test phase. So the test phase is you and I. We've started testing. So it's still amber. We've completed testing. We take it to integration phase. Integration phase. Then we move it further inside the green. Then it it gets delivered to the user. Are you happy? Then fine. Everyone is happy with that. Then we are done with that phase. Then again, we go into the backlog. This time around is search functionality we want to pick. We pick the search functionality, we commit it into our sprint. Everyone is happy. We understand what questions do you have? Yes, we don't have this. Then we put it into development. The developer finished developing, he puts it through to the tester integration. We go through this loop as many times as it is within the sprint. So this is mainly how agile works. That ends. So it's just a fantastic way to say I'm sticking this into you. So requirement is done. Build one, design and development, testing, implementation, build two. Same iteration, just on that phase. So that ends the whole of software development lifecycle. So now that takes me to software testing lifecycle. Software testing lifecycle. Before I continue, I'll just navigate quickly to the chart. So in the chart, let me see. Okay, thanks. Please, under verification and validation, um, in vModule, what are the main functions of acceptance testing test plan? System test plan, integrated test plan. So at this phase, acceptance testing, there are there are different phases. So in every for a user for a requirement, there are acceptance testing to validate it. So what you need to do,
Right.
Sorry. Okay. So at this phase, when every verification for the acceptance testing plan, what you need, don't say acceptance testing plan, just say acceptance testing. So for the acceptance testing, what your expectations are, what are the criteria, what are the things that we need to validate to be able to work with the specific requirement you have given. So take user login. There are, in this user login, with the acceptance testing, what you will get is different criterias, different things. The user story or the requirement details, we have a lot of things, a lot of yardsticks that you're going to test with. So when you are creating your own test cases, this acceptance testing, you have to create test cases to validate it. So for instance, for login, the acceptance testing of it will go that it will go to say, if so for the acceptance testing of it, you will have you will have um login. In the login, can you log in with blank details? So she will tell you unable to log in with blank details. All those steps you will tell you. Then what are the criteria? It should be 8 character alphanumeric. It should have special character. So those things that are needed are the acceptance things that will be validated, that will be written in the acceptance test plan. For the system test plan, so what are the system test plan? How is the system going to react? Take it from this phase that we want to say, for system tester, what are the things that you are going to use to validate this system test plan? You have been given the application. What do you want to test here? In the login, this is what you want to, these are the measures that you want to use in the system test plan. I want to check when I'm given the application, this is how it is working. This is um, the system itself that I'm playing with. This is the application itself. So everything you are going to test, that you are going to use, are already written as part of your script. So this is what is going to validate it on the system in the application that you are using. Then integration phase. What is the integration? End to end, bringing together everything as it works. We have done login. After you log in, the next phase is you want to make sure that it goes to a landing page. It's an integration mode. Integration mode, it also entails the bit of the automation part of it. They are also you integrating, even acceptance testing, um, system testing, all these are part of end-to-end testing. Then for the unit testing, I told you it is code wise. So this entails writing code. It's mainly done for automation testing. For manual testing, codes are not executed. Thoroughly, I must say so, but we can also review code by peer reviewing with either the developers, him explaining to you what is happening at every phase of the code. That's the way it is. So these are the things we need to understand. So unit testing and connect them both before we get to coding. So these are, it's just every phase that you see there, the requirement is you reading through requirement, the acceptance criteria is just reading through the requirement, listing out what is accepted for that requirement. System, I have the application. What is accepted is what I am using for the system. Integration is everything coming together as one. Are they linking up? That is it. Then unit testing. That is the phase that we look at. I please, why is security not incorporated into build from the beginning? Because they mentioned that the development team are Scrum Masters, BA, design tester, etc. But no security mentioned. Why? So, so what it means here is security testing is is a form of, you could be a security tester. As I've been saying, it depends on the application you are working on. These are names of roles. We are still doing the same thing. You, as a security tester, you are part of the development team. If the job you are working on or the application you are working with is security, is security, um, is dealing with security, talk about penetration testing. All these things are, that's the reason. It's not that I'm not saying it's part of it. I only put, look, development team is also wide. They have different types of developers. Them what Scrum architecture, there are different phases of it. You call some solution architect, you call some functional architect, you call some process. So it depends on the name given to that role. But the big person there is that they are still under the umbrella of testing. So that's why it's not that I segregated it or I'm saying I did not put them as part of team. These are like placeholder. Placeholder is part of the things I use as the development team. Project manager, product owner can be under, it depends on how they do it. PMO can be there. So it depends. Scrum master. So they all have, we all have entity in development life cycle. That's what it means. So that takes us to software testing life cycle. Sorry, let me check my time. So I just got 10 minutes, and I'll give you 15 minutes. We talk about it. So software development life cycle, software testing life cycle. So now you would have been wondering that I specifically waited to talk about development life cycle to make sure that you understand that I was carrying everybody along. When I mean everybody, testers, developers, project and program manager, project project manager, scrum master, data analyst. I was bringing everybody in to that picture. That's it. But this time around, it is us now. Software testing life cycle is a life cycle for we testers. This is what we are meant to do as part of our job. It now streamlines to tester. Now, the difference is that development, software development lifecycle is for the development team as a whole. Software testing lifecycle is for testing team processes, procedures as a whole. Two different things. How does this work when it comes to us? So we've got the requirement analysis phase, which I've explained previously. We've got after the requirement analysis, once we require the requirement starts, how we start our job, how we execute our job is what software testing lifecycle is telling you. It's a process, it's a procedure. You must follow it. Most organizations will tell you there are processes we follow. This is blueprint for all of us. So the first thing is requirement analysis. We've been called into a kickoff room. What is kickoff room? We all gather together. This is the project we're going to work on. Yemi, you're going to be working on of course I know I'm going to be doing the testing part of it, as that is my role, that's my responsibility. So that is it. We all have an idea of the project we are going to do. So the next phase for me is that I need to start doing my testing prep. That's my testing preparation. What does this mean? It means I'm creating my test plan. That is my activity. Now, can someone remind me? That takes us to something we were teaching when we did the first class, fundamental test process. That is what software development lifecycle is all about. See? So, for software development lifecycle, we'll be talking about the fundamental test process. And for fundamental test process, we do the test planning. Don't forget, there are 5 phases of it: test planning and control, test analysis and design, test implementation and execution, evaluating exit criteria, test closure activity. Those are the 5. So now this 5 is what we are coming here. So from test planning and control, we do the test design. The test design, what does the test design implement? So start designing your test cases, start bringing them out. So this test planning is a wide one. We are still going to teach you how to write test plan in by next week when we do our class. We should be getting there. So test planning, there's a way we construct test planning. It's you can do test planning and also test strategy. You'll be taught how to do that. Then the next one is test design. Next class, maybe by next week, if not tomorrow, but that will be next week. I'll tell you how to design a script, and I'll tell you what my expectations are. Environment setup. Sometimes, most of the time, it's going to be done by the developers, or if it's a big organization, they have the environment team, infrastructure team. They take ownership of that. Test execution, that's done by you and I. So the test cases you've written here, we need to execute them. Don't forget, that's the third phase of the fundamental process: test implementation and execution. Then the final bit of it is test closure report. That is our life cycle as testers. So going further, what is STLC? It stands for Software Testing Life Cycle. It's a sequence of different activities performed by the testing team. You know, I in fact I forgot to underline this and bold it. Is testing team to ensure the quality of software or the product. To ensure the quality of the software or product. So that's our activity. What is the role of STLC? One, even with the most talented, highly skilled team of developers, mistake can still happen as a result of human nature. Remember, what is error? These are the mistakes we are talking about. Hence, but because of error, those defects is the reason we have this STLC life cycle, so that we too can follow the rigor of testing properly. Developers can do the testing. They can they can test from the development point of view. We test from the testing point of view, from the user's perspective, from the expectation of both the requirement from both business. It is our job. The role of software testing lifecycle is to identify any mistake that have been made and find solution for them, helping to maintain the quality of every piece of software produced and ensuring that the project requirements are met. So the phases. So now we're talking about the software testing life cycle. It consists of 6 main phases, each of which involves specific actions designed to ensure that a high standard of performance and quality is achieved. The 6 main phases are: one, requirement analysis, test planning, test case development, environment setup, test execution, test closure, test cycle closure. So now, everything I've mentioned in the development phase, I'm bringing it as the process, how we as testers are meant to work. So the first one, what are the activities that you are meant to perform when you are doing requirement gathering? When you are listening to your user stories, when you have your user stories, what are the things? What are the activities? One, identify the types of tests to be performed and assigned to the development. What type of test are we going to talk? I'm still going to teach you types of testing. We've got various types of testing to be performed. Are we going to do functional testing, non-functional testing? We are going to do regression, retesting of bug fixes, compatibility. It depends on the application you're testing. So I'll still talk about that also in the next class. So the next one is gather details about testing priority and focuses. So what are the focus? What are the priorities? You need to gather any question you have at that phase. You need to find out when they bring different scenarios out. What I do, what I do is that prior to a kickoff, you would have been seeing emails would have been going through to say, oh, project X is going to come up. There would have been some documents that would have gone out. Now, I tell people there is nothing new that would have not been created before. What do I mean? If you are going to test a mobile application, tell me, how many versions of mobile application do you have? We can, in fact, we would even lose count when it comes to mobile testing. The difference is just features that are going to change. Maybe one will add the camera can see from here to the moon. That's the only thing they want to add to it. But the big question is it still a mobile phone? Yes, it's still a mobile phone. Do we have mobile phone existing in the world? Yes, we do. Talk about a website. If you if you want an e-commerce website, Google is a friend. Open there and type it. You see millions of websites, different ideas. So the first thing I do is that before I go to such a meeting, I would gather information, make my knowledge kind of wide, so that when I start asking different scenarios, oh no, we didn't think about it. Oh yes, we thought about it. This is what. Oh, we can. So those are the discussions that goes on when we are doing. Then the next is prepare requirement traceability matrix. This is key. Mm, Of course, I, as a professional tester, I know most people don't. They don't do this. But there's no organization that I've gone to. I will always speak about this. It gives you good coverage, requirement traceability matrix. It makes sure that you understand that you have covered every script. To be honest with you, in my script, in my script, I'm saying even as of today, that you, of course, we all went to, if I'm my scripts that I design, I always, if you give me a script and I don't see the requirements there attached to each of the script, it's not complete for me. Because it makes you know that I've covered this requirement, you've covered this requirement, you've covered this requirement. It gives you a backing that you have tested everything expected from requirement perspective. At least you have a test attached to a requirement. Hence, this is necessary. Now, you might ask me, how is this done? Just simple spreadsheet. That is what I use in doing it. An Excel spreadsheet, open it, write it in your format, put it. Which script have you written? Your test case, it should be part of it. The first step I do is requirement analysis. That's my requirement details. I put this, I put that, I put that. So those things I'm going to explain to you later. So all this can be part of things. Requirement traceability matrix. We're still going to talk more about it. Identify test environment details where testing is supposed to be carried out. Conduct automation feasibility analysis if needed. There are some times that some um, some tasks are not automation candidates. We have some that are automation candidates. What does this mean? Automation candidate. Uh, it means that it means that you want to If you want to automate an application, it's something that people, a lot of people use frequently. Frequently, that's what people expect you to automate. But our advice in the internship, automate as much as you can automate if you want to, just for learning purpose. But the main thing here is that at the end of my course, if you've done at the end of manual testing, if you've done your assignment, your mentor or your bodies have looked at your test cases, if you're confident enough and you've gone through this class, you understand what I've been saying, if you're confident enough, you can put through a manual testing CV and just try yourself out there. When you have this thing, if you want, in terms of um, interview prep, we can help with that. So those are the activities of requirement gathering. So what are the deliverables? I'm making this so easy. Requirement traceability matrix. This document maps and trace requirement proposed by the client with test cases to ensure that every requirement has an associated set of test cases assigned to it. It's a must. The requirement that you know that you don't have a test case to it, flag it. Flag it. Flag it. And when you're flagging it, don't flag it via a chat. Flag it via an email. Copy it, send it to your test manager. We don't have this. Don't let them respond to you via chat. Respond to you via email. Reason is that I'm working in an organization where I've tested something maybe 3 years ago. The only tester before we started getting people onto it. It's a big application, so it was too big. I couldn't. So I had quite a number of people to help out. But the thing there is, every test case that I test, as long as if I'm the one that worked on that application, I document my test evidence, no matter how you want the deadline for. As I'm looking at the first page, I'm taking a screenshot and putting it. I save it up. After then, once I finish testing, I put a step to each of them. The reason why I always do that is that so that when that application, because I know the application we are working on is going to still go, is going to take longer because there are new things coming in. So, and I know the gap in the particular data that we're working on. So it was a big one. We found it difficult when we were doing it. There was a lot of scenarios that wasn't able to execute. But by and large, I was sent an email that, oh, Yemi, every other person they just joined the project. So they are 2 years into the project. You've tested this. We saw an email that you tested it. I said, yes, I did test it. What did you test? I said, no, you didn't test this. And I brought everything out with all the evidence. I told them that go back to your code till so time and check. Then when we went back, retracing the step back, it was the deployment that they made that code not to work. I've got test evidence. I've got how it worked. Everything with date timestamp on it. Nobody, up to now, nobody can even call me to tell me that this didn't work. So we didn't bother to go further. So if I didn't have a test evidence, if I did not map my test cases to that, then I didn't do my job properly. So hence, I always preach, please, just make sure that no matter how small it is, make sure that is covered it shows how we do it. Then automation feasibility report, if applicable. This report will be produced as a result of analyzing the project, working, let me see, the project, analyzing the project, working out what the screen have components that can have automation testing written against it, the complexity of writing the automation test, whether the test cases includes large amounts of test data, among other facts. So you will have to understand what your automation candidates are, what needs to be tested. So for tonight, I'm going to stop here. I'm not going to go further than this. I'll go back to the screen and I'll take my questions from here and I want you to talk. So that ends the class for today, but question and answer. I can't go further because I need us to talk, then I can ask my question. So Rose, you can stop. You can